Interpolation. So we have talked about interpolation before when interpolating surface normals from vertices to fragments and so on. But now this interpolation relates to images. So a raster image is sort of like a 2D array of values. We can call it a matrix if we want, but it has these point values at coordinates. It does not have infinite resolution. It has some fixed resolution, and we can sample these point values from the images. However, our 3D surface is continuous, so we might rasterize a varying amount of these points for a face. So if we have mapped this image onto a face or a triangle or a square, we might see this face closer to the camera, so we need more resolution, and if it's further away, then we sample it with less resolution. And this brings us to textures. So this is maybe a bit creepy image, but here we have a texture. So this is a 2D image, and parts of this image are mapped to the faces of this model here. This marine character has this clothing and skin and boots and well face. He even has teeth that are visible on this image. So parts of it are mapped to the marine model to give it more detail. But this marine model could be closer to the camera, so we need to sample this texture with more detail, or it could be further away, so we have to make it smaller. Upscaling is if we want to see the surface in more detail, then we have values on the image. We need to upscale the image somehow. So let's say we have this very small texture, this 2x2 texture with 4 point values, and we want to map it to a surface of 3x3 values. So each of these is like a pixel that we want to color according to the value that we have to sample from the texture. The elements of the texture are usually called texels to distinguish them from elements here that are pixels or pixels on the screen. So we have pixels and we have texels. Now for a single pixel in the larger surface, we usually have 4 neighbors in the texture. So if we want to sample a value here, we often have 4 neighbors that we can use to interpolate what this value should be. Well, the exceptions are if we want to sample, let's say from here, then we only have like one closest value to sample from. Now there are 2 common logical and very simple ways to sample that texture. On the left we can see the nearest neighbor sampling, GL nearest. So to know what value we should draw on the screen for this coordinate, we just take the nearest texture value, the nearest texel that we have to this sample point, and we draw that. This results in quite a pixelated image. So another way would be to do this bilinear interpolation, this GL linear. It's called bilinear because we use the 4 neighbors. We linearly interpolate between them in the vertical direction and then among the results in the horizontal direction. So we use all these 4 neighbors to calculate this sample point value. Now there are other parameters in OpenGL as well. So like GL clamp to edge, GL clamp to border, GL mirrored repeat, GL repeat. So those relate to when we want to sample from a coordinate that is outside of the texture range. So those textures are usually in this UV space, where the U-axis is the horizontal axis and goes from 0 to 1, and the V-axis is the vertical axis that goes also from 0 to 1. So 1, 1 would be the top right corner of the texture, 0, 0 would be the bottom left corner of the texture. But if we would want to sample from, let's say, the coordinate 0, 2, then that value would be up here, or that coordinate. But our texture has ended. So what should the GPU do? And these are the different options. So if it's clamped to edge, then it's just gonna take the nearest value on the texture. So it would revert back to 0, 1. Clamp to border would allow us to define a specific value that we would always get when we sample from outside the texture. Repeat and mirrored repeat the texture. So for example, if it's 0, 2, then this texture is repeated, then it would take a sample point from here. This is often useful if we want to tile some kind of a surface with a small image that can be tiled to repeat along a larger surface. Mirrored repeat would do the same thing, except the repeats would be mirrored. Downscaling. So we can use the same schemes for downscaling. So let's say we have this big 5x5 texture and we want to downscale it to this 3x3 sampling grid. So we have a sample value here, we have 4 neighbors, and we could take the nearest neighbor. Or we have a sample value here and we have again 4 neighbors, and we can do the bilinear interpolation between those 4. Now this runs into a small problem. So let's say we have this kind of a texture where we have black texels and we have white texels. So most of the image consists of black texels, but there are some white spots in the image as well. So if we would now downscale to 2x2, the sample points would end up here, and the 4 neighbors of those sample points would be all white texels. So our 2x2 downscaled result would be a completely white picture. This is not entirely correct because our texel was mostly black, so we would expect to have some sort of a darker gray result, not white. Later on in the materials we will see how this is remedied in computer graphics. From this video you should understand raster images and textures. You should understand upscaling and 2 interpolation techniques, the nearest neighbor interpolation scheme and the bilinear interpolation scheme. And you should also understand downscaling when we want to depict a larger image on a smaller surface, and what can go wrong with these simple interpolation schemes when downscaling.